Tendon modeling tools in OpenBridge. My name is Alexander Maverick, and I'm a senior consultant within the Bridge Group. So, how we design bridges today, and what are we proposing to do now, especially with this new BIM workflow, building information modeling, that everybody wants to do BIM, everybody wants to do 3D modeling. And what Bentley proposes is that our 3D modeling should be the centerpiece of our information. I mean, we're proposing a model-centric approach to do our designs. Then, from that 3D model that we create, that physical model, that BIM model that you create, we will go to analytical model. In our case, on this presentation of today, is we will develop a segmental bridge in OpenBridge Designer, in a MicroStation environment, in a DGN format, and we're going to send this to our analytical solution, that in this case is OpenBridge. Now, after we finish this, we can send this to planks production, rebar detailing, 2D detailing. And when we finish that, we, of course, deliver our projects and send it to construction, inspection, load rating, all the extra activities. What we want to mention is that the center of all of that is the MicroStation environment. We're used to say MicroStation is a CAD software, right? Is drafting. Well, actually, no. MicroStation is for real a BIM platform. All our softwares now, all Bentley software, OpenBridge, OpenRoads, OpenRail, OpenBuildings, they all write into a common format that is the DGN file, a MicroStation file, if you want to call it like that. And through a federated model, meaning through a referencing, you have a live bridge, but then you reference, you federate the information coming from roadway via a reference file, for example. And all of them are live. So if the alignment changes, your bridge may move. If you update the profile, well, the bridge, if you allow it, will move. So again, MicroStation becomes the common format for all Bentley applications, right? And all of that are softwares, apps, if in this new terminology now, and they are called open because that's what they are. They write the information into an open format that is MicroStation for us. Obviously, as you are used to MicroStation, there is no versioning issues. There is no that, oh, you have to upgrade because if not, you cannot read the file, right? So that's that. Now, what is the tool that we're going to use for modeling purposes? OpenBridge Designer. OpenBridge Designer, it's the product for us in Bentley that creates that physical model of the bridge, the big model. Then that model is used to do the analytics and the plans production. Now, what we have in OpenBridge Designer, right? So we have a big model creation. You can do the whole geometry layout, right? Analysis, design, plans production, all of that visualization, all of that information that you generate is done in OpenBridge Designer, a 3D model for that. Now, all this information that you generate and then your bridge itself, it becomes the centerpiece. OpenBridge Designer is the one that encompasses the 3D model creation, but at the same time, internally, it uses LEAP software, LEAP Bridge Concrete, LEAP Bridge Steel, and now also OpenBridge to calculate the analytics of your bridge. After the bridge is done, then you can send it to ProStructures for detailing, Navigator for maybe manager's review, GINT to interact with Geotech, or a full-blown visualization with reality modeling through LumenRT. Okay. And the interface is just one. With OpenBridge Designer, right, you create the 3D model and you open Bridge Modeler to create your bridge. Now, for today's presentation, we're going to skip the modeling part. This is another SIG for that. But we're going to consider that with OpenBridge Modeler, we have already done a segmental bridge like that. And a segmental bridge that is going to be done through the balance cantilever method. OpenBridge Modeler can model a bridge, a segmental one, with two methods. Maybe considering, as this is, balance cantilever, or could be by span by span. So we're going to do a modeling like that, or we're going to consider that we have already done this model in OpenBridge Designer. But this model, we're going to take it again with this balance cantilever method to RMBridge. RMBridge will be the one in charge of that analytics, right? And in OpenBridge Modeler, we have already decided how it's going to be constructed the cantilever, what is going to be the construction sequence, right? And then RMBridge will be in charge of analyzing all of that, right? But one of the challenges inside any software is to get the proper tendon layout and how we're going to stress all these tendons to make the calculation of our bridge possible, right? And achieve what we want to achieve at the end, right? So in the whole workflow, this is what we're going to do. We're going to consider again that the bridge is already done. So I developed this with OpenBridge Modeler. My bridge, my segmental bridge. Actually, I even define the construction sequence or the stage construction in RMBridge. In OpenBridge Designer, right? So now I'm ready to perform the calculations. So for that, in OpenBridge Modeler, I said, oh, this is a segmental bridge. So let's send it to RMBridge for design purposes. Okay. Now, keep in mind, the keyword is send it, right? I didn't say export it. I didn't say transfer it. Yeah, maybe it's little semantics here, but it's very important because I'm not exporting information. I'm not translating information, because by the moment in the BIM methodology that you say export or translate, you are dealing with a different format. And then you have to check and double, and in this case of these bridges, you maybe triple check that maybe you can lose some information. We don't do that, right? We just say send it to RMBridge. Just by in OpenBridge Modeler, we just say connect to RMBridge and send it that data, right? And it will create for us the analytical model. OpenBridge Modeler give me the chance to review what I'm sending. I mean, this is kind of a 10-span bridge with all the piers, cabs. I can set up the materials right here. If I didn't set it up already in OpenBridge Modeler, I can set it up even in RM. I can check the support conditions that I enable, and that model is transferred directly to RMBridge. So RMBridge is launched internally for an OpenBridge Designer, and I got the bridge. And it's set up already for a structural check, meaning that when I run it, RMBridge has already figured out, again, the construction sequence, the loading, the depth load that is applied, because it knows, again, the segments and all of that, and it performs for me what is called a final structural check of the bridge. So if it's feasible to work, right? So then I can review very quickly, just for dead weight, the moment diagrams, the shear diagrams, basic, I would say basic, a response spectra design on all of that, right? And with the spectra that you select. So if everything passes, at least for dead weight, final conditions, I know that my bridge is feasible and I can continue. Because it could happen, for example, that I have, too many deflections, even on seismic. So I know that I have to change maybe some structural elements of the bridge, for example, right? So I'm done on that part, right? So the structure right here is structurally sound. Deflections passes, the moments are in general between the range that I consider are possible. So my next step is now to confront the tendon layout of that bridge, right? So then on that, as I transfer the model, I gotta check, right, how are we going to do this, right? Now, as I said, the balance cantilever method allows or asks for a tendon definition, right? So you need to define that harp, right? That it will establish my tendon sequence and how it's going to lay it out. I mean, that could be a good example. The challenge on that also, the tendon layout. Usually in software, this is a 2D operation. Here we considering the 3D of the tendons, right? Because again, we are laying out these cables in the 3D model, right? And it's not like you're going to draft it, okay? Don't get me wrong on that. Is that we're going to use the software to allow me to do that. But first, what I need to define is, as you can see here, where the tendons are going to go, right? So I got the concrete box section, but where are the ducts that I need to define in the section itself for design where these tendons are going to go? So OpenBridge allows me to create the ducts location, where they're going to go. So if this is my section right here, right, I can use in OpenBridge the grid array command in OpenBridge to define that is going to be tendons, for example, or tendon locations or tendon ducts all along the wings of that span. Now, I want to mention here that this is my locations, for example, right, that I'm going to set up in OpenBridge, right? But look at the numbering or the naming convention that I use, because it's important, because it will make my job easier when recognizing what tendons are going and their location. Okay, so for example, you got this TLIO. So it's tendon layout, now internal on one side, right? Inside, outside, 0. Tendon left, 0, 1. Tendon left, 0, 2. Oh, on the other side is tendon right, 0, 1, right? Tendon right, 0, 2, right? Tendon right, tendon left, internal on the left side, 1. Outside, 0, 1. Okay, so just keep in mind that this is a tendon naming convention that has truly worked for us, because it makes it easier to identify where are they located, right? So as it's going away from the center of from the flanges here, I know which one is the interior, which one is the exteriors, right? And the increasing number, it means that they are going away. And this is the harp that we need to develop on each side of the box, right? So this is what we need to create. And well, again, how we're going to create it, right? So for that, I need to define first the tendon's location with precision. So I use that grid command, right? And it's going to be array. So it's going to be a series of equally spaced ducts, right? So what I do is I select what we call the construction line. So basically, if you want, from this axis, okay, and along the horizontal axis that I have defined for my section. Now, who has defined this axis? When you brought the cross section from OpenBridge Modeler, it has created all these axes for you. Okay, so you don't need to worry about their location and all of that. So what we're doing here is we're saying on the basic command is following the vertical line, CL1, right, at a certain distance that I'm going to set up, right, create a series of duct locations for that, right? And then starting at a certain line, right, also at a certain distance. So because I don't want, you see, that line to be right on the edge, right? So I just want it at the center location. And then the naming convention that I mentioned to you. Okay, TL, right, left outside, started with 1 at an equally space. And then I just hit OK. and I will place that tendons, ducts. Okay, so did it, and actually, right? Oh, they are not on the right side because again, when I did this, right? Remember, this was CL1, the horizontal one, and the other one was the center line 3 was the vertical one. So I can need to fix it, right? Because on that definition, right, is again, I want to show you again that definition of the left on the right. So again, I select the same command, right? So being the CL1 is the baseline, right? The horizontal one. And then you can see what was the mistake about that the CL1 horizontal, but I want 4 units to the right. That was to the right of that line. So, and then the vertical was okay. See? So now I got a good definition on the tendons, right? And then that will be the interiors to the outside of the flange. I will need another definition now for the right one and the internals too, right? So now I have to come up with, again, another dimensions, right? So same on the right side, and now I have the tendons, ducts for that part of the flange. Now I have to do the same process for the right one. So that's how we define all these tendon ducts for us, right? And the process gets repeated. Now I can use a different line, right? So now CL1 is still the horizontal one, right? But then it's going to be what? It's still going to be units, 4 units maybe, to the right, right? But then also to the left to define that, right? So this is how you define all these tendon ducts for us, right? And so on the right side, right, it will be a different name now, right? On right outside, so it means they're going to be here, and 6 units to the right, but then since this is my base, it's going to be to the left, and then I have that. And then again, I repeat the process now with a different distance for the interiors ducts on the right side. So, and then I can continue defining all the other ducts, but I think you got the point on how to do these tendon locations. Along these points, the tendons will go, right? And then I need to enable my definition, right? And also change the numbering as well. Remember, the numbers are going to the outside, right? And these editing options allow me to do all of that. And then again, I just can keep going, defining all the other tendon locations. And it's just a matter of using the same command over and over. Okay. So now what will be then the next step, right? Since I will have all the locations ready to go, right? So then the next step is to set up the tendon properties, right? What kind of cables are going to go? So for that, then I call the tendon tool. Now these tendon tools on the layout is on extras, preprocessor, cantilever, the new balance cantilever method. We still have one for legacy purposes, right? There are still bridges set up with all methods, so we still have to keep it, but this is the new methodology, right? So the first step is define the tendon properties. What is going to be the area of the tendons, how many are going to be, what is the friction factors, what is the wobbling factors, the angle of attack, all of that needs to be defined first. And then as you can see here, these are all these tendon ducts location that we have defined previously. Right? So we got the 3D model of the whole bridge, the tendon ducts all along each one of the cross sections that I have is a standard. And then here, what I have is the numbers of the sections. So every section, every segmental box here, when we transfer from OpenBridge Modeler to RM, it has been assigned a number, right? So call it a structural number if you wish. And on the side, it shows the tendon names or the tendon ducts in which we can go our cables through. Okay, so what we did again, it would just define the tendon properties, the tendon physical properties of that. So now we have to start the tendon on, for example, a particular pier table and then go away from that, right? So we can zoom in, we can switch to transparency, but again, what number was assigned? Is that number or box number 100, box number 107, right? So we need to find that out. On the tendon properties, you can define it, or we can just select it from the catalog that you can also develop. And just define a tendon group, any information, and enter the area of the duct, the area of the actual cable itself. And that's where we're going to go next on now, how we're going to lay out all these tendons and find out what are these numbers at the top correspond to the actual structural element that we see on that 3D model. So we have done so far just to set up, as I said, the tendon properties. So now let's go to the tendon layout, right? And remember, this is the harp that we have to set up, right? So then this comes the heart of the presentation. This is how we do it. So we need to lay out the tendons, right? All along, going to different ducts, right? In the section. So, as I said before, on this one, right? The software automatically recognizes and highlights that, oh, if I click here, that is going to be the position, the left interior, right? On the section box being highlighted here. And that element 110 is actually the pier table, right? So, and that's how it does it, right? Oh, no, mistake. It needs to go further down. So it actually needs to be, I will need to start that from that particular element. That's how we started then. See, so you get immediate feedback on the graphics, and that's how you're going to start also in this tendon or in another one, right? So then you really know where are you placing these cables. Now, the instructions on how to place it, they are way at the bottom. So basically you select in which positions they go in every element. You select the tendon number that you want to assign, right? And also remember that you're going to pull these cables, so you need to verify the stresses they are going through. So I'm going to apply a stress label. So, stress on left tendon 1. So I know the stress that is going to be attached and check the results on that, right? And the factors that I use that are going to apply for the tendon, and I just say create it. So now the prefix was T, so that's my T1 tendons, right? And you see also the immediate feedback on the 3D model, right? Now, the next part of the harp, right? So it's going to be going from element 115 from the same position, right? TL01, and also, and look on the right side here, how this is changing in location. So you know exactly where you're going your cables through, right? So now it comes tendon 3, right? So one more time, you go and count, and it's going to start from this side of the box, and these are going to be the locations. So you select that. Now, one more time, see how this is changing here. This is the ducts that are going through, and they say create another tendon. So it's going to be tendon 3, right? And then you're gonna go tendon 4, tendon 5. Every element also is being displayed here, right? And also in the 3D model, you can get where the tendons are going. So maybe you made a mistake, or you are maybe going through the same duct uh, with the same cable. So that's a no-no. So you can just also verify it on the 3D model, right? And remember, you're only doing the uh, left inside part of the harp on the left side of the box, right? So we need to repeat that same process to the left side on the outside of the box, or the wing, if you want to call it like that, right? So how you do this, right? As we mimic this process. So you keep going and doing that first section of the harp, right? Now, also, you set up the software to increment the number by 1. So that's why you have tendon 1, 2, 3, 4. And this one that is coming now, it's going to be tendon 5, right? Got it. So create the tendon. At any time, you can change the properties if you need to, but I mean, this should be working okay, right? So now, as I said, now this goes on the left on the inside. So now, using Shift and Control, I can select the whole configuration. And I said, I need to mimic the same operation to the outside of the box. So I can go on the same place, right, with the size of the box, and I can do Control C, Control V, copy paste, right? But it cannot be just a straight copy paste, because remember, it has to be a harp, right? Harping effect. So what we do is, as we select it, we just can go and say copy paste mirror, right? So here I will repeat the same operation, right? But look, now I'm going to the right side, right? So copy mirror, and that's it, right? So my tendon 1, it becomes now, by 5. So it's tendon 6, tendon 7. So it just has created that whole configuration. So I got basically the two insides working, right? Now, could I have done the inside, outside on the left and the inside, outside to the right? Yes. But it's just a matter of how you're going to count your tendons. So basically I have tendons from 1 to 10 all working on the inside of the box. And maybe the other ones will be the outsides of the box. So again, it's all up to you how you want to number your tendons and which one you want to consider the inside or outside for that. Because here, for example, right? So now I finish working here with the inside left. So now I can do the same operation for the outside on the left. I can do copy paste, or I can copy paste mirror, or I can increment the number by something completely different. So I know that maybe from 1 to 10 tendons are the interiors, and from 20 to 30 are the exteriors. So it's just a matter for you how to decide that. Or maybe on the interior, it's a different tendon layout. And that's what you can do here too. And apply the copy paste process into that. So as you can see, there are many different ways to handle these, but at least for me, this has been a great improvement in how easy you can do these tendon layouts. And if it's going to be more elaborate, and then you want to save these results, right, or save this input, right, so you can save these tendon layout into a TCL file in RM and just load it every time you need it. Kind of sort of saving a template for you, right? Because remember, this is attached by numbers. So if you just, have the correct numbering schema, so then you can really adding or subtracting numbers to the layout, you can really accommodate to any kind of structure, right? So here, basically, I'm repeating the process to do it on the outside tendons on the left side. And then I'm going to do copy paste mirror for the tendons on the right side on the outside, right? Could I have done it differently? Of course, because it's just all, it remains on how you want to do these copy paste operations, right? And then also what tendon numbering you want to use. So it's, again, it's up to you how you want to do this. And this will do for one pier, right? One pier table. Now, if you complete the whole process, right, you can just have all the tendons highlighted, meaning a big box of highlights, completing all the way from left outside to right outside, and then copy paste to the next pier, and to the next pier, and to the next pier. So you have an 11 span bridge. Well, you just do copy paste 11 times, right? Just playing with the numbering offset that you want to apply, right? So maybe plus 10, so everything will be moved 10 units. So you will have finished here with tendon 30. So the next one will start maybe with tendon 40, stuff like that, right? So again, it's just a matter, I would say, you just have to play with your numbers here, right? And complete, and then the same operation will apply, right? The copy paste mirror when you finish doing all these tendon elements, right? So the process in general could take maybe 10 minutes, right? If you already know your numbers, you know how you're laying out. So it's pretty simple rather than defining this before every location by coordinates. And also remember, these locations are being read in the 3D model. So the actual tendon itself is going into a 3D element and is calculating all these stresses that are happening when you go 3D. Okay, so it's a way more advanced calculation than just pulling a simple cable, right? So when you finish this process here, then you will go copy paste, mirror, and then you will have a full tendon layout for that pier, right? So the next step is then highlight the entire operation that you did in one pier, right? Make it maybe pier 2 and copy paste all of that to the next one, right? And then you can just move the records here, right? So now we did it in pier 118, so maybe the next one is plus a certain distance, right? So then 18 records apart, so then you just paste it, and then you have the next tendon layout, right? And that's it. So the next one will be next pier line. Maybe there are 10 more segments in this span. So will you do copy paste and say move the records and copy them 10 units ahead. And then little by little, you will complete whatever number of spans you want to set up into the bridge. Got it? So simple enough. As I said, it's just laying out. What you have to be careful though is just, of course, highlighting the proper ducts that you're going to go through your tendons and through what sections they're going, right? The 3D model will help you on the layout. The ducts in the cross section will help you on the layout as well. What elements are you highlighting or you are considering, right? So after that, you got two options, right? One option is proceed with your design. So actually on the segmental loads, add your live loads over the other extra loads. So proceed with the full bridge design here, right? So that will be part of the analytical, right? Now, when you finish the analytical, or at any time actually, what you can do, and let's assume that we have already laid out all these tendons now, and then also I add the live load, so I just finish the design of the bridge and my design passes. Or I want to see how the bridge looks like, right, with the tendons. So the next step is to transfer all these layouts that being on the analytical one, right, and then as I go to next groups and next groups, is to transfer this design back to OpenBridge Modeler, right? So as you can see, I can continue with the tendon layouts if I need to. So the next step will be, as I said, to go to transfer to OpenBridge Designer. So then here what I do is I will say update my design with whatever information is coming from OBM, right? And update it and run it. So as I accept that, I will bring the file that it was created by RM and bring the graphics back. It's doing the graphics on that. And when it finishes the entire process, the software will just rail out the bridge and create the entire process for you. Right, so it's not only taking a little, I would say long, not long, but it's just realigning the whole bridge and loading all these tendons for that 11 span bridge that you have done into the 3D graphics. So it's actually creating MicroStation elements there, right? And it's just laying out your bridge with that new tendon information also through the proper docs. So it's loading the entire information there. And when it finishes, that's it. So now if I zoom closer, right, I have all the tendons that I laid out along the box at that proper location. So that's the same tendons that it went to RM, right? Now they are part of OBM. Right? So as you can see, going from analytical to the actual BIM model. Right? Now, is that a BIM model? Yes, that's a BIM model, right? Because these elements that came, right, is not just lines in MicroStation, as you can see, right? So look, let me isolate the tendons here, right? And these tendons, as I said, they are no mere graphics, right? If I go and select that segment, right? So I just isolate it here, and these are the tendons now. But then what does it make it a BIM model? Because look, these elements now are not, as I said, just lines, but actually has properties. And what properties? The tendon properties that you provide in the analytical model. You see not only the tendon locations, but also the tendon properties, right? The tendon length. And more than that, what tendon actions were done in the analytical file, and you can see the stresses that are happening. Okay, and that makes it a true BIM model. Okay, so because you're bridging the gap, no pun intended, between a physical model and an analytical one. And then basically with this, you can design, right, any kind of segmental bridge that it may come to you. Like, for example, this Macau Bridge project. Remember that? Right now, this is the longest precast segmental box in the world. Okay, done in RM. Now, in general, right, if you want to learn more about this, we strongly recommend you to go to our Learn server that is actually active to all our users with your subscriptions. So just look for Bridge Training, OpenBridge. If you type Find Training OpenBridge, it will give you all the learning path for all our bridge products, not only OpenBridge Modeler, but RM and Leap Steel and Leap Bridge Concrete. Also, we have subscribed to our channel, Bentley OpenBridge. We are constantly populating for small videos, on how to do specific tasks on all our bridge software, right? And also, we invite you, to our weekly sessions on Ask the Experts. So every Thursday at 11 Eastern Time, we're hosting a very quick half an hour, but very informative at the same time, of a question and answer session, open question and answer session. And we give you the latest tips and tricks, the latest bridge news, the what is coming in our software, and of course, I'll always asking for your feedback on what you want to see in our software or even in future presentations. And that's all I have for you. Thank you, and we're going to go now to the question and answer session. I see some of you already populating the chat window, so let's go ahead. So one more time, guys, thank you so much for attending this SIG meeting. Remember, we do this once a month. The SIG, the special interest group, is actually the second Thursday of every month. So thank you again in the name of our product manager, Afshin Hatami for RM, and your senior application engineer, Alexander Mavrich. So thank you so much and see you next time. Bye-bye.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you and see you next time.